Hi. In continuation to the sessions on correlation coefficient, today's session will be on Spearspan rank correlation coefficient. In our last lectures, we tried to discuss different cases of Karl Pearson's coefficient. Now, today we'll be discussing Spearspan rank correlation coefficient. Now, before getting into the calculation part, it's better to know where to use Karl Pearson's coefficient and where to use Spearspan rank correlation coefficient. See, we might come across two different types of situation. First situation where it is very easy and conducive to measure a particular variable, right? For example, somebody's height, weight, demand, price, etc. Right? That means these variables are measurable variables in absolute terms, right? So these are measurable in such a way the quantification is very easy. In such cases, always go for Karl Pearson's coefficient. But in our real world, some variables come as qualitative variables, which cannot be measured to the highest perfection, right? Variables like honesty, beauty, voice, these are not absolute measurable variables, rather, these are relative measurable variables, right? One person's honesty cannot be measured in a standard way, right? It may vary depending on the person who is recording. Similarly, beauty, from person to person, the score may vary, so there is no standard scale to measure beauty. Similarly, in case of voice, so if we come across variables which cannot be measured or which are of qualitative nature, right? Then Spearspan correlation coefficient replaces Karl Pearson's correlation coefficient, right? So it's very important that before applying, you need to understand the nature of the variable. Now, it's not that we will be using to only those variables which have been given in ranking orders, right? Sometimes we might get a problem where variables have been given in values, right? But it's our intelligence which will guide us to understand what is the nature of our variable, right? I'll take an example. Suppose in a music show there are two judges and one person is performing, right? Now the same music can have different impact on both the judges. So they might give their scores in numbers as we have taken in this, right? But as there is no standard scale to measure voice, that is why these values are not absolute values, but these are relative values. Therefore, instead of doing Karl Pearson's correlation coefficient, it is better to go with Spearspan rank correlation coefficient, right? Now, when I say rank correlation coefficient, uh, it should be noted that rank is something which gives you an understanding of which is of higher quality and which is of lower quality, but how much higher or how much lower, it does not give you that idea, right? So in such instances where you have always a confusion that how much good, right, or how much bad, you are unable to calculate, in that case go for rank correlation. So Spearspan rank correlation coefficient is also named as rank correlation coefficient. Now it is denoted by, so we'll have two cases in this session. we are discussing case 1, which is non-repeated ranks. We'll see what is non-repeated ranks. Now, this is the fundamental formula for Spearman rank correlation coefficient, right? It is denoted by RS, whereas Carl Pearson's was denoted by only R, right? So Spearman correlation coefficient is denoted by RS equals to 1 minus 6 sigma d square by n square minus 1, where d is Rx minus Ry. That means rank X minus rank Y. N is number of observations, right? So we have been given a problem. Calculate rank correlation coefficient for the following data. And we have two values, X and Y, right? See, as I told you in the beginning itself, that sometimes we might get values also where we are supposed to apply Spearman, right? Now, how to apply Spearman on these things? X, right? So add one more column named as Rx. Now what is Rx? Rx is the ranks of these values. Fine. Now how to rank this? For ranking, pick up the least value. Pick up the least value, which is 59, and rank it 1. Fine. Next, after 59, the next value is 68, rank it 2. Next, 68, after 68 it is 69, so rank it 3. After 69 it is 78, so rank it 4. Then the next number is 79, rank it 5. Next number is 89. Just a minute, I'll do the exercise once again, right? So first was 59, so 1. Then is 68, so it is 2. Then is 69, so it is 3. Next bigger number is 78, so it is 4. Next bigger number is 79, so it is 5. Next bigger number is 89, so it is 6. And last and the highest number is 97, so it is 7. Right? So the order which I have followed is increasing order. I have ranked all the numbers starting from 1 and followed an increasing order, right? So this is the ranking of X. Similarly, we'll rank Y. Go for the least value, so it is 107, so it is 1. Then next value which is higher than this is 112, so it is 2. Next is 124, so it is 3. Next is 125, it is 4. Then 136, so it is 5. Next is 137, so it is 6. Lastly, it is 156, that is 7. Right? Now, we need to get D. And what is our D? It is Rx minus Ry. So rank X minus rank Y. So 4 minus 4 is 0. Right? Likewise, 6 minus 6 is also 0. 7 minus 7 is also 0. So I've got the differences. Right? 0, 0, 0, 1, 0, 0, minus 1. Now we have to get D square. So get D square. That means this difference value square of this. So 0 square, right? 0 into 0. 0 into 0, right? Likewise, for each value, we have drawn the square. Now, let us come. We'll use the formula. It is Rs equals to 1 minus. Now, 1 minus sigma d square. So let me add this. So 6 into sigma d square is 2 divided by n square minus 1. So n is 1, 2, 3, 4, 5, 6, 7. 7 square. That means 7 into 7 minus 1. Right? So Rs equals to 1 minus sigma. See, 6 into 2 is 12 divided by. See, it is 7. 7 into 7 is 49 minus 1. Fine. Therefore, Rs equals to 1 minus 12 divided by. See, this is 7 into 48. Right? So, Rs equals to 1 minus, now it is 12 divided by 7 into 48 equals to 336. Right? Therefore, Rs equals to 1 minus, if we divide 12 by 336, we get 0.035. So 1 minus 0.035 equals to 0.965. Right? So remember, we usually answer 3 things. Right? First, X and Y are related to each other. Second is X and Y are positively related to each other. Finally, the degree of relationship between X and Y is 0.965. Right? So it is much easier than Carl Pearson's coefficient, right? Because we need not to do bigger calculation in this. The reason behind not having bigger calculation, that we are converting the values into ranks, right? So ranks, usually it is in single digit number, and the two, we are taking differences of 2 ranks, so generally it gets converted into single digit only. Correct? So the calculation is easy, but we need to understand where to use this. One more thing to inform you, not necessarily every time you will get an absolute value and that you need to convert into ranks. Sometimes you will get ranks only, right? So if you are getting rank, you need not to worry about X and Y. You can only solve by Rx and Ry. Once you get rank, go for the deviation of ranks, then square of the deviation and then put the formula, right? But if you get absolute values and either you are informed that please use Spearman rank correlation coefficient, or it's your intelligence which is guiding you to go for Spearman correlation coefficient, then convert these values into rank, then the deviation of ranks, and then square of deviation. Right? Hope you have understood the concept. So for any further query, you can contact me on this email ID, right? You can contact me on this email ID. Thank you.